So in section 2.10, we're dealing with what's called the tangent line problem. And before we actually discuss that, we're going to talk about an algebraic concept that's very important in mathematics. And work a couple examples. And then we'll talk about the tangent line problem. All right. So this expression right here, down here in C, is called the difference quotient. And it is an important algebraic expression in mathematics. So we're going to compute the difference quotient for a couple of functions. Okay? I'll just walk you through it. So the first function is a quadratic function. F of x is equal to 4x squared minus 2x plus 9. And so we're going to do A, B, and C. So there's like 3 steps to calculating, computing the difference quotient for a function. First, we're going to evaluate the function f at x plus h, find f of x plus h. Then we're going to find this difference, f of x plus h minus f of x. And then we're going to divide this difference by h, right? And then we'll have computed the difference quotient, okay? So, how do you evaluate f of x at x plus h? Now, I will have to admit, you may want to write a small. There's not a lot of room to write out f of x plus h. F of x plus h minus f of x. Okay. How do you evaluate f of x plus h? Wherever you see an x plus x on the right-hand side of f of x, you replace it with x plus h, right? So we have 4 times x plus h squared minus 2 times x plus h plus 9. Now we got to expand that and simplify, right? Combine like terms. So x plus h squared is the same as x plus h times x plus h, right? So to expand that, you gotta FOIL, okay? So this is equal to 4 times, when we FOIL, right? First terms, x times x is x squared. When we do outer, we have h times x. When we do inner, we have h times x. hx plus hx is 2hx. And then when we do last, we have h times h, which is h squared. So x plus h squared FOILs to x squared plus 2hx plus h squared. Let me add this. For those of you who got to take Calc 1, this is extremely important you understand this. Okay. Now here, we can distribute the minus 2 inside the parentheses. And we have minus 2x minus 2h. And then lastly, we have the plus 9. Now I'm getting all this on one row on my paper, but I'm writing really small. Okay. But now you got to distribute the 4 inside the parentheses here. And we have 4x squared plus 8hx plus 4h squared minus 2x minus 2h plus 9. See any like terms? I don't see a 1, right? I mean, look at everything, just write it coefficients, right? Write it for x squared, hx, h squared, x, h, constant. So this is it. That's f of x plus h for this quadratic function. So far, so good. All right. Step 2 now, right, in calculating the difference quotient is to calculate f of x plus h minus f of x. Well, f of x plus h is everything in the rectangle. 4x squared plus 8hx plus 4h squared minus 2x minus 2h plus 9. From that, we subtract f of x. Now, I strongly recommend that you put, when you subtract, put f of x in parentheses, because you're subtracting every term in f of x. Students have a habit of not putting stuff in parentheses, and then they subtract the first term, but not the second and third. It messes up the entire problem. So now you distribute the minus sign inside the parentheses. And you have 4x squared plus 8hx plus 4h squared minus 2x minus 2h plus 9. You gotta be careful not to change a plus to a minus, minus to plus, drop the letter, all that good stuff. And so 4x squared becomes minus 4x squared, minus 2x becomes plus 2x, and plus 9 becomes minus 9. If you do this right, all three terms of the function f of x will cancel out corresponding terms over here. Okay. So when we combine like terms, you see that 4x squared minus 4x squared is 0. Minus 2x plus 2x is 0. And plus 9 minus 9 is 0. If you do it right, every term of the function, f of x, will cancel the term over here. So what are we left with? 8hx plus 4h squared minus 2h. That's f of x plus h minus f of x. That's the numerator of the difference quotient. Okay. Any questions on that algebra? Those of you got to take Math 120, you need really good pre-calculus skills. Okay? Very important. All right. So now we can do C. And C is f of x plus h minus f of x over h. So now we know the numerator is 8hx plus 4h squared minus 2h. Now, there's two ways to simplify this. We can divide each term in the numerator by h, or we can factor out, you notice each of these terms have h in them, so we can either factor out an h, or we can divide each of the three terms individually by h. How would a young college student do it? What would you do? Divide each term by h. So this is equal to 8hx over h plus 4h squared over h minus 2h over h. Okay. Remember, fraction bars are like division symbols. Division does not do addition and subtraction. Okay, so you got to divide each of those terms by h. Well, in this first quotient, the h's cancel, and we're left with 8x. Rules of exponent in the second quotient, h squared over h is just h. So we're left with 4h. And then in the third quotient, h is canceled. We're left with minus 2. So the difference quotient for this function, f of x, this quadratic function f of x, simplifies to 8x plus 4h minus 2. Yes, ma'am?
Can we just factor out the h from the numerator?
You could, right, and then I was asking about that. So let's do right the other way, okay? So what she's saying is we have 8hx plus 4h squared minus 2h over h, right? You can factor out an h in the numerator, right? When you do that, you have h times 8x plus 4h minus over h, right? H is a common factor in those three terms, so you can factor out h. And now when you, those two cancel, and you're left with 8x plus 4h minus 2. Same thing as we got over there. Okay. All right. Any questions, ladies and gentlemen? Okay. All right, let's take a look at the next example. So in example 2, we're given f of x is equal to square root of x plus 1 minus 3. Alright, we just took exam 2, right? Riddle me this. F of x is a transformation on what function? Square root function, right? So you know what the graph square root function looks like, right? So you wouldn't have any problems graphing this one, right? You would shift the square root function to the left 1 unit and then down 3 units, right? And then you would have this graph. Okay. All right. So f of x plus h, wherever you see an x on the right hand side, you put in x plus h, right? So we have the square root of x plus h plus 1 minus 3. Can't do anything more than that. Yeah. Now we find f of x plus h minus f of x. F of x plus h is the square root of x plus h plus 1 minus 3. And then we subtract from that f of x, right? And so, since there's more than one term in f of x, there's 2 terms, put it in parentheses. Now when you distribute the minus sign inside the parentheses, you have the square root of x plus h plus 1 minus 3 minus the square root of x plus 1 plus 3. Minus 3 plus 3 cancel. And we're left with x plus h plus 1 minus square root of x plus 1. So, right, so this is f of x plus h up here, and this is f of x plus h minus f of x down here. You can't simplify that any further. Now the difference quotient, f of x plus h minus f of x over h. We divide this in the rectangle by h, right? And we have the square root of x plus h plus 1 minus square root of x plus 1 over h. And you can't simplify that. Now, we did learn in section 1.5 how to rationalize the numerator, right? How to rationalize the denominator. What we're going to be doing next, right, is you would have to rationalize. In order to do what we want to do next, you would have to rationalize the numerator. So, let me give you a reminder. You don't have to dig these notes up, but we have. So, exam 1 material. Remember I have said that math is cumulative. So remember here we are, section 1.5. You had to memorize all these formulas. Okay? And we learned how to simplify various rational expressions using those formulas. And one thing that we learned, a couple things that we learned back in 1.5 was how to rationalize the numerator and how to rationalize the denominator. Okay? So in order to accomplish what we're going to talk about next, you would have to rationalize this numerator. Right? So we're going back to section 1.5. Okay? What we're going to talk about next requires knowledge of 1.5. Okay? Math is cumulative. Okay? So if you flip over your page, now the very last page is blank. So what I'm going to draw on the board, you might want to draw on the very last page as a reference. I'm going to talk about what is called the tangent problem. Tangent line. We all know how to find the slope of a straight line, right? It's rise over run. That's exam 2 material, right? The slope, so here we are in an XY plane. We have a straight line, and the slope of that straight line is rise over run. Okay? Well, in mathematics, we're interested not in just the slope of a straight line, but in the slope of a curve at each point. Okay? You'll notice that this curve, right? Remember, we read graphs from left to right, right, in the quarter plane. And so going from left to right, we're going uphill, and then we get to the top of the hill, and then we're going downhill. So the slope is positive, right, until we get to the top of the hill, and then the slope is negative after the top of the hill. Okay? Going uphill and then downhill. So one problem we're interested in mathematics is how do you measure the steepness of a curve at each point, right? The slope is changing constantly, going from left to right. How do you measure how steep the curve is at each point? We can do it with a line. We just need 2 points on the line, and we calculate rise over run. And we know how steep the line is at every point. Well, so let's say we're interested in the slope of this curve at this point right here. There is a line that just touches this curve at that point, and that line is called a tangent line. The word tangent means to touch. There's a line that just touches the curve at that point. And it turns out that the slope of the tangent line and the slope of the curve at that point are the same. Okay. Slope of the tangent line equals the slope of the curve. We calculate the slope of the tangent line, we know what the slope of the curve is at that point. Okay. That requires the difference quotient. Okay. That slope involves a limit. So going back to section 1.5 again, we studied limits. Okay. So do you remember back on exam 1, right? You had to find limits, right? As x approaches some number, right, for some function. And so all kinds of, right? It might be kind of foggy because we haven't talked about it since exam 1, okay? But back in section 1.5, we learned how to calculate the limit of a function as x approaches some number. Okay. Well, the slope of this curve at this point of tangency is equal to the limit as h goes to 0 of the difference quotient, f of x plus h minus f of x over h. So we're back in section 1.5 now, calculating limits. Okay? In your handout, instead of the word slope, we have this fancy mathematical notation here. And this is read f prime of x. F prime of x is equal to this limit. Okay? So this is read f prime of x. So what your handout calls the derivative of f at x, right, is how you calculate, is read f prime of x, and that's how you calculate the slope of the curve at that point. Okay. So we're not going to delve into this real deeply, right, but you need to be exposed to it. So let's do an example. Let's look at example 3. We have f of x is equal to the square root of x. So to calculate the derivative of f of x, f prime of x, right, we got to calculate the difference quotient, right? So we have f prime of x is equal to the limit as h approaches 0 of the difference quotient, f of x plus h minus f of x over h. Well, f of x plus h is put in x plus h where you see an x on the right hand side, right? So we have the square root of x plus h and minus f of x, which is just the square root of x. I intentionally made this problem with not a lot of math in it. Okay? And that's divided by h. Now, when we were doing limits back in section 1.5, do you remember what the first step was in evaluating a limit? What was the first step? Do you remember? It was called direct substitution. You put the number, right, that x is approaching, in for x into the function, and if the value of the function equals a real number, right, at that value of x, then that's the limit. Okay. So if we put in 0 in for h, right, it's h. So it's not x that's approaching 0, it's h. put 0 in for h, we have the square root of x plus 0 minus the square root of x over 0. Well, x plus 0 is square root of x, so we have square root of x minus x in the numerator over 0 in the denominator. And square root of x minus x is 0. Right? Anything minus itself is 0. And so we have 0 divided by 0, which is undefined. Well, what we learned in section 1.5 is even though the function is undefined at h equals 0, okay, the limit still may exist. Okay? That's what we learned in section 1.5. So first we did the direct substitution, and if we ended up with 0 over 0, we knew we had to manipulate this algebraic expression because the limit could still exist. Okay. So what we have to do, okay, is factor the numerator, not factor the numerator. My mind. Rationalize the numerator. So we have to rationalize the numerator. Okay. Well, does anybody remember when we're involving square roots, how we rationalized the numerator? Do you remember? We multiplied top and bottom by the conjugate of the numerator. You remember the word conjugate? So the conjugate, just to review, the conjugate of a minus b is a plus b, right? And the conjugate of a plus b is a minus b. And the reason for that is when you multiply a minus b times its conjugate a plus b, you get a difference of squares, a squared minus b squared. And that gets rid of the square roots. So, we're going to multiply top and bottom of our difference quotient by the conjugate of the numerator. So we have in parentheses square root of x plus h minus the square root of x. And the conjugate of the numerator is the square root of x plus h plus the square root of x. And that's over h times the square root of x plus h plus the square root of x. Okay. So I multiply top and bottom over here by the conjugate of the numerator, and the conjugate of the numerator is square root of x plus h plus the square root of x. So the numerator is of the form a minus b times a plus b, right? My a is square root of x plus h, and my b is square root of x. And so a minus b times a plus b is a squared minus b squared. Okay. So the numerator simplifies to, what's a squared? Right. Remember this, when you multiply this out, you get a squared minus b squared. Well, a squared is square root of x plus h squared. Right? Squaring undoes the square root, and you're just left with x plus h. B squared is square root of x squared, which is just x. So we end up with minus x all over h times the square root of x plus h plus the square root of x. Now in the numerator, we're left with x minus x, so they cancel. And we're left with the limit as h goes to 0 of h over h times the square root of x plus h plus the square root of x. And now you can see the h's cancel. And we're left with the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Now you do the direct substitution, right? You put 0 in for h, and you're left with one over the square root of x plus 0 plus the square root of x. X plus 0 is x. Square root of x plus square root of x is 2 times the square root of x. And this is equal to 1 over 2 times the square root of x. So f prime of x, the derivative of f of x, is equal to 1 over 2 times the square root of x. So if you want to know for the square root function what the slope of the curve is at a particular value of x, you just put that value of x into the fraction over here. That tells you what the slope of the curve is at that value of x, how steep it is. I know this is a lot because we haven't looked at 1.5 for a few weeks now, right? But math is cumulative, okay? So we don't forget what we learned in 1.5, right? We bring it with us, right, to the to exam 2 and exam 3 and exam 4. All right. I want to give you plenty of time to take a quiz. And we can't do, I don't think we can do the last problem in a couple of minutes. So we'll stop here and take our quiz, and we'll do the last problem